Section 1. Introduction to computer networks. A computer network is a collection of interconnected devices that can communicate and share resources with each other. These devices can include computers, servers, printers, and other peripherals. The primary purpose of a network is to facilitate the exchange of data and information between these devices. Networks enable users to share files, access shared printers, and communicate with each other through email, instant messaging, and video conferencing. Resource sharing is a fundamental aspect of computer networks. Networks allow users to share hardware resources like printers and scanners, reducing the need for individual devices. Additionally, networks enable software sharing where applications and data can be accessed from multiple devices without the need for physical installation on each computer. This shared access enhances collaboration and efficiency in various settings. Networks can be as small as a home network connecting a few devices or as vast as the internet, connecting billions of devices worldwide. The underlying principle remains the same, enabling communication and resource sharing among interconnected devices. The benefits of networking are numerous, ranging from increased productivity and collaboration to enhanced communication and access to information. As technology continues to evolve, computer networks continue to play an increasingly vital role in our personal and professional lives. Understanding the basics of computer networks is crucial for anyone who interacts with technology. From sending an email to browsing the web, nearly every aspect of our digital lives relies on the seamless operation of these interconnected systems.
CAD, Section 2. Types of computer networks. Computer networks can be classified into different types based on their size, geographical coverage, and purpose. The most common types of networks include local area networks, or LANs, wide area networks, known as WANs, metropolitan area networks, or MANs, and personal area networks, or PANs. LANs are privately owned networks that cover a small geographical area, such as a home, office building, or school campus. LANs typically connect a small number of devices, ranging from a few to a few hundred. They are characterized by high data transfer rates and low latency, making them suitable for applications that require fast and reliable communication. WANs, on the other hand, cover a large geographical area, often spanning cities, countries, or even continents. The Internet is the most prominent example of a WAN. Unlike LANs, WANs are not typically owned by a single organization, but rather by multiple entities that collaborate to provide connectivity. MANs fall somewhere between LANs and WANs in terms of their geographical coverage. They typically cover a metropolitan area, such as a city or a town. MANs are often used by organizations that need to connect multiple locations within a city, such as businesses with branches in different parts of the city. PANs are the smallest type of network, covering a very limited area, typically within a person's reach. Examples of PANs include Bluetooth connections between a smartphone and headphones, or a wireless keyboard and mouse connected to a computer. These networks are designed for personal use and typically involve low-power, short-range communication.
Wow, I didn't realize there were so many different types of networks. This really helps me understand how diverse networking can be.
CHAT. Section 3. Exploring network topologies. Network topology refers to the arrangement or layout of interconnected devices in a network. There are several common network topologies, each with its advantages and disadvantages. Understanding these topologies is essential for designing and implementing efficient and reliable networks. The star topology is one of the most common network topologies. In a star topology, all devices are connected to a central hub or switch. This central device acts as a central connection point, relaying data between devices on the network. The advantages of a star topology include its simplicity, ease of management, and fault tolerance. In a ring topology, devices are connected in a circular pathway, where data travels in one direction around the ring. Each device on the ring acts as a repeater, amplifying the signal and passing it to the next device. Ring topologies are relatively inexpensive to implement and offer good fault tolerance. The bus topology is a simple topology where all devices are connected to a single cable, known as the bus or backbone. Data transmitted by one device travels along the bus, and all devices on the bus receive the data. However, only the intended recipient processes the data. Bus topologies are simple and inexpensive to implement, but are prone to signal degradation and collisions. Mesh topologies are characterized by interconnected devices, where each device has a point-to-point connection with one or more other devices. This redundancy creates multiple paths for data to travel, providing high fault tolerance and reliability. Mesh topologies are often used in critical applications where network downtime is unacceptable. Hybrid topologies combine elements of two or more topologies to leverage their respective advantages. For example, a network might use a star topology to connect devices to a central switch, while using a bus topology to connect multiple switches. Hybrid topologies offer flexibility and scalability, making them suitable for complex networks.
WALT Section 4: Essential Networking Devices. Networking devices are the hardware components that facilitate communication and data transmission in a network. These devices perform various functions, from connecting devices to controlling data flow. Understanding the roles of these devices is crucial for managing and troubleshooting networks effectively. Routers are essential networking devices that connect different networks and direct data packets between them. They act as gateways, determining the optimal path for data to travel across networks. Routers use routing tables to determine the best path for data packets based on destination IP addresses. Switches connect devices within a network, similar to hubs, but they offer more intelligence in managing data flow. Unlike hubs that broadcast data to all connected devices, switches learn the MAC addresses of connected devices and forward data only to the intended recipient. This selective forwarding improves network performance by reducing unnecessary traffic. Hubs are simple networking devices that connect multiple devices in a network. They act as central connection points, broadcasting data received from one device to all other connected devices. Hubs operate at the physical layer of the OSI model and do not perform any intelligent data processing. Modems modulate and demodulate signals to enable communication between digital devices and analog communication lines, such as telephone lines or cable lines. Modems convert digital signals from computers into analog signals that can be transmitted over telephone lines and vice versa. They are essential for accessing the internet and other WANs. Access points provide wireless access to a wired network, allowing devices like laptops, smartphones, and tablets to connect to the network wirelessly. They act as bridges between wireless devices and the wired network, extending the network's reach and providing flexibility for users.
That's a lot of devices. I can see how each one plays an important role in making sure a network runs smoothly.
Section 5: Understanding network protocols. Network protocols are sets of rules and standards that govern how devices communicate and exchange data over a network. These protocols ensure that data is transmitted and received correctly and that different devices can understand each other. TCP/IP, or Transmission Control Protocol Internet Protocol, is a suite of protocols that form the foundation of the Internet. TCP provides reliable, connection-oriented communication, ensuring that data is transmitted without errors. IP is responsible for addressing and routing data packets across networks. HTTP, or Hypertext Transfer Protocol, is the protocol used for transferring hypertext documents, such as web pages, over the internet. When you access a website, your web browser uses HTTP to request and retrieve web pages from a web server. HTTP defines how messages are formatted and transmitted between browsers and servers. FTP, or File Transfer Protocol, is a protocol used for transferring files between computers on a network. FTP enables users to upload, download, and manage files on remote servers. It is commonly used for website maintenance, file sharing, and software distribution. SMTP, or Simple Mail Transfer Protocol, is the protocol used for sending and receiving email messages. When you send an email, your email client uses SMTP to send the message to your email server, which then relays the message to the recipient's email server.
Section 6. Basic Network Security Measures. Network security is crucial for protecting sensitive data and preventing unauthorized access to computer networks. Organizations and individuals must implement appropriate security measures to safeguard their networks from various threats.
Firewalls act as barriers between a trusted network and untrusted networks, such as the Internet. They control incoming and outgoing network traffic, blocking any traffic that does not meet predefined security rules. Firewalls can be implemented in hardware or software and are essential for preventing unauthorized access to networks.
Encryption converts data into an unreadable format, making it incomprehensible to unauthorized users. It uses cryptographic algorithms to scramble data, making it impossible to decipher without the correct decryption key. Encryption protects sensitive data during transmission and storage.
Antivirus software is designed to detect and remove malicious software, such as viruses, worms, and Trojans. It scans files and programs for known malware signatures and quarantines, or deletes infected files. Regular antivirus scans and updates are crucial for preventing malware infections.
Section 7, IP addressing IPv4 and IPv6. IP addressing is a fundamental concept in computer networking, enabling devices to uniquely identify and communicate with each other over a network. Each device on a network is assigned a unique IP address, which is used to route data packets to the correct destination. IPv4, or Internet Protocol version 4, is the most widely used version of the Internet Protocol. It uses a 32-bit address space, providing approximately 4.3 billion unique addresses. However, with the rapid growth of the Internet, the number of available IPv4 addresses is dwindling. IPv6, or Internet Protocol version 6, is the latest version of the Internet Protocol, designed to address the limitations of IPv4. It uses a 128-bit address space, providing a vastly larger number of unique addresses, effectively solving the IP address exhaustion problem. IPv6 offers several advantages over IPv4, including a larger address space, improved security, and better support for mobile devices. It also simplifies network configuration and improves routing efficiency. While IPv4 is still widely used, IPv6 adoption is steadily increasing as the Internet continues to evolve. Section 8. The OSI model, a layered approach. The OSI, or Open Systems Interconnection Model, is a conceptual framework that divides the communication process in a computer network into 7 distinct layers. Each layer performs specific functions, and layers interact with each other to enable communication between devices. The physical layer is the lowest layer of the OSI model, dealing with the physical transmission of data over a communication medium, such as copper wires, fiber optic cables, or radio waves. It defines the electrical and mechanical specifications for data transmission, ensuring that bits are transmitted and received correctly. The data link layer is responsible for reliable data transfer between adjacent nodes on a network. It provides error detection and correction mechanisms to ensure that data is transmitted without errors. The data link layer also manages MAC addresses, which uniquely identify devices on a local network. The network layer is responsible for addressing and routing data packets across networks. It determines the optimal path for data to travel from source to destination and manages network congestion. IP, the Internet Protocol, operates at the network layer. The transport layer provides end-to-end communication services between applications on different hosts. It ensures that data is delivered reliably and in the correct order. TCP, or Transmission Control Protocol, and UDP, or User Datagram Protocol, are examples of protocols that operate at the transport layer. The session layer establishes, manages, and terminates communication sessions between applications. It allows applications to establish a dialogue, exchange data, and synchronize their actions. The presentation layer is responsible for formatting data for presentation to the application layer. It handles tasks such as data encryption, compression, and character encoding. The presentation layer ensures that data is presented in a format that the receiving application can understand. The application layer is the highest layer of the OSI model, providing services to applications that enable them to access network resources. Protocols such as HTTP, FTP, and SMTP operate at the application layer.
Section 9. Benefits of computer networks. Computer networks have become, well, indispensable in modern society, offering numerous benefits that enhance communication, collaboration, and access to information. From businesses to individuals, networks have revolutionized the way we interact with technology and the world around us. One of the primary benefits of computer networks is enhanced communication. Networks enable instant communication through various channels, including email, instant messaging, and video conferencing. This real-time communication facilitates collaboration, improves decision-making, and strengthens relationships. Networks also facilitate resource sharing, allowing users to share hardware and software resources. Instead of each user requiring their own printer, scanner, or software applications, networks enable these resources to be shared among multiple users, reducing costs and improving efficiency. Centralized data management is another significant advantage of computer networks. Networks allow organizations to store data on central servers, making it easier to manage, backup, and access data from multiple locations. This centralized approach improves data security, integrity, and accessibility. Networks also promote collaboration by providing a platform for users to work together on projects and share ideas. Shared workspaces, online collaboration tools, and cloud-based platforms rely on networks to connect users and facilitate teamwork. Furthermore, computer networks provide access to a vast amount of information through the internet. Networks connect users to a global repository of knowledge, news, entertainment, and countless other resources. This access to information empowers individuals, fosters innovation, and drives progress in various fields. Section 10. Future trends in networking. The field of computer networking is constantly evolving, driven by technological advancements and the ever-increasing demand for faster, more reliable, and secure networks. Several trends are shaping the future of networking, transforming how we connect and interact with the digital world. The Internet of Things, or IoT, is a rapidly growing network of interconnected devices, from smartphones and wearable devices to home appliances and industrial sensors. These devices collect and exchange data over networks, enabling automation, remote monitoring, and data-driven insights. Edge computing is a distributed computing paradigm that brings computation and data storage closer to the data source, reducing latency and improving response times. Edge computing is essential for IoT applications, where real-time data processing is crucial. Software-defined networking, or SDN, is a networking approach that separates the control plane from the data plane, allowing network administrators to manage and control network traffic programmatically. SDN offers greater flexibility, agility, and automation in network management. 5G and Wi-Fi 6 are the latest generations of cellular and wireless networking technologies, offering significantly faster speeds, lower latency, and increased capacity. These technologies are transforming mobile connectivity, enabling new possibilities for streaming, gaming, and other bandwidth-intensive applications. Network security remains a top concern as networks become more complex and interconnected. Artificial intelligence, or AI, and machine learning are playing an increasingly important role in network security, enabling proactive threat detection, automated incident response, and improved security posture. Section 11. Conclusion: Networks in a connected world. Computer networks have become the backbone of modern society, connecting us to each other, information, and countless devices. From the internet that connects billions of users worldwide to the local networks that power our homes and businesses, networks have transformed how we live, work, and communicate. Understanding the basics of computer networking is essential for anyone who interacts with technology. From sending an email to browsing the web, Nearly every aspect of our digital lives relies on the seamless operation of these interconnected systems. As technology continues to advance, computer networks will continue to evolve, becoming faster, more intelligent, and more pervasive. The future of networking holds immense potential, with emerging technologies like the Internet of Things, edge computing, and 5G poised to revolutionize how we connect and interact with the world around us.